is useful for all others also. Can I have a small recap? You can unmute yourself, please. Am I audible? Maybe can I request Mr. Anand? Can you briefly share what we have seen in our last sessions? Can someone volunteer, please? Can someone volunteer? Hello, am I audible? Gokul, can you confirm? Am I audible? Yeah, I am audible. Thanks. Okay, I need some feedback, please, participants. Let's make it a little interactive, because today what we are going to see is almost a wrap up of what we have done with the particular data set of how we can predict the next day whether there will be sufficient power in the battery, as well as the generation in the solar power plant will be sufficient for that day's consumption or that day's load. Okay, so we are going to wrap it up by seeing how different models can be fitted in that. Okay, so what are the difference between the random forest or other type of models? Okay, that is what we are going to see, but obviously we have to recap. So I think almost 50% I have recapped what we have seen. Okay, if somebody can repeat this also is okay. Kindly give a feedback whether you are able to understand it or you want any particular segment to be repeated. First of all of you got the codes of our last session. Have you all received the R code of our last session? Can you please raise your hand if you have received the code to your mail? Mr. Venkat, I think I don't have that type of control to maximize my screen, but you can zoom in Teams. That is possible for me if you want to zoom into separate part of the screen. Yeah, can you all confirm whether you have received the code? Can you all confirm? Who not received? Okay. Okay. So I think Mr. Anand, you have registered in the link. I hope so, right? Yes. Okay. So Gokul, can you see why it's not sent to Mr. Anand? Mr. Anand, can you put down your email ID in the chat window? Could there be some problem or some spelling mistake? Maybe when we are copying and pasting inside the email ID, inside the email. Kindly put down your email ID. Yeah, Google, kindly forward to that particular email ID, and please check if Mr. Anand's email ID in our database is same. Okay. So, Mr. Venkat, you have received the code? Can students of BIT, can you please confirm whether you all received the code? Okay, so you also haven't received. Okay, Gokul, let's plan at least like before this particular session ends. To all the participants, kindly resend the code once again. I think you have the code with you. Okay, and request all the participants to confirm whether you have received the code. Okay, before end of this particular session. Okay, let's go into the session so that we save some time. Okay, fine. So what I have tried to do is I try to use the line package. Okay, let's give a small introduction about line. Okay, and before that, let's see what is explainable AI. So let's pick this images. This one, image. Okay. So see, AI, when you talk about artificial intelligence and machine learning, what happens is many times, let's use Wikipedia, the open source. So many times what happens is that particular model becomes a black box model. So what is happening inside, obviously we know what is random forest, but what is happening inside we don't know, right? So that is the very important problem. Okay? So that problem people call that as a interpretability problem. So we are not able to interpret what this particular model is doing or how the model is making a decision. So that is the important problem in the AI community, which has emerged in recent days, I would say. Let's see the history of explainable AI. So it has started in 1970, but it had gained momentum in the recent past, say some 10 years back. This started, especially when people started speaking about the GDPR, that is the General Data Protection Rights. Okay, how their data is being used, and there are some cases like, or I would say the legal cases like, if a loan is being denied for a specific person, why the loan is getting denied? Okay, what is the reason? The model is saying like, for me, loan is getting denied. How it is rating like I am a defaulter or I am a probable defaulter. So those kind of sensitive things when it came inside during that particular time, this explainable AI become very important. Okay, and there are some cases, maybe in the Wikipedia also they have mentioned that there is some racial, yeah, yeah, race. Racial means there are some discrimination. People started telling like the model is discriminating me based on art. You can see here. See, in 2010, public concern about racial and other biases are being used in AI. For example, even the Google, when you are Googling something, okay, so for one person, the results will be different. For other, the results are different. So those kind of things came into picture. And increased usage in medical devices also paved the way for explainable AI, because when in medicine, whenever the model is saying like there is a likelihood of this particular person getting a this particular disease, okay, so we also have to have an interpretable decision of the model. We want to know like how this particular model came to this particular decision. Okay, so that is the very important aspect. Okay, so that is the reason this explainable AI gained momentum, and nowadays this becomes I would say like a de facto standard. If you ask me the state of the art, maybe explainable AI is the research topic many researchers would like to take whenever they are having a ML or an AI based research work. Okay, so that is the state of the art as of now. And there are a few images which also show like how the models are making mistakes. Okay, so you can also dig down deep into this and understand how it is. Okay, so now why we are talking about explainable AI? What is that we want, if at all, an explainable AI to be used in our business case? Okay, can someone give a pointer? Why explainable AI we have to use in our problem, or the problem what we were working in the last 3 sessions? Please, participants, please be interactive. Kindly unmute, kindly speak. That's very important. Students, BIT students, kindly speak, unmute. And I can see there are a lot of professionals from leading companies you have been here. Kindly participate. Only then, I think mutually we all will learn. Can I have some answers, please? Friends, without an answer, I'm not going to proceed. Let's make it like that. Okay. So without someone talking to me, I will not proceed. I don't want to have a mono dialogue. Okay. So I'm muting. I need some answers from people. How explainable AI can be used? Can I have some answers, please? I don't know whether it is not audible only for me. Is someone speaking? Gokul, can you confirm if someone's speaking?
No one, sir. I'm able to hear your voice.
No one. Okay. So I need some response, please. Someone kindly speak. So I want to understand why explainable AI we are going to use in our use case. Why we are going to use. Darshan, can you give an answer, please? Or Mr. Keshav, Mr. Anand, Mr. Venkat.
Mr. Somasundram, this is Venkat.
Yes, Mr. Venkat, please.
Yeah, am I audible?
Loud and clear, sir, please.
Okay, thank you. So this is the first session I'm attending anyway, so I'm not sure what has happened in the past, but given what you're talking about AI probably applicable to the power side of things, okay, with my experience, I'm trying to share a couple of thoughts here, though not maybe related to what is happening. So the whole point here is you're trying to predict, maybe see what, depending on the pattern that was consumed in the past, kind of machine learning would have happened. I mean, going by what you're showing, okay. So some data would have been captured or gathered, and that would have been entered or captured in a database. You're trying to query that and predict the future of in terms of what could be the consumption patterns, or when is it going to fail, when is it going to shoot up, or when is it going to go down, or something like that. So that was a very wild guess. Correct me if I'm wrong, or if there is some other angle to the whole thing, I'd be more than open to understand and probably share my thoughts around.
Thank you, sir. Thanks for the feedback. I think you are almost there, but obviously, as this is your first session, maybe we have to, we will introduce you what is the data set we are working, and probably you will understand how we are going to use this expanded AI here.
Sure,
Yeah,
sir.
yes, sir.
Sorry to quickly add a point here is you don't have to, for the sake of just me, you don't have to repeat everything. Probably I'll catch up as it goes. Okay. So probably I'll be there. Don't worry about it. But just keep continuing and I'll probably follow up whatever.
Okay. Thank you, sir. Thank you. Thank you so much. Thank you. Thank you for this conversation. Yeah. Mr. Anand, please go on.
Forecasting without any bias, something like that.
Okay. Yeah. One of the answer. Yes. So any other answers? I saw Dhanapriya. Can you give your answer, please? Thank you, Mr. Anand. Yes. Ms. Dhanapriya, please go on. Ms. Dhanapriya, you want to answer? I saw you raising your hand. Okay. I think this is by mistake she raised. Okay. Any other answers? Fine. So then let's go inside. Okay. Fine. So just for the benefit of everyone, let's recap what we have seen. So what we are trying to do is we have a data set which is being given as part of a book, okay, and we have used that particular data, and that data was having different columns, okay. Let's go to a point where we can see the expect. Okay. So this particular data set was from home and probably or an industry, okay, and they are having a solar power plant in their roof, and they are having some DC loads, and the load is called load energy or load 1 or load 2, and they are also having an inverter which is converting the DC into AC, and there is AC loads. Momentarily, it is taking that particular load. Okay. So this is the data set that we have, and what we started to do is that this is all time series data. Over time stamp, we have this particular data. That means every second, every minute, this data will have. So what we thought is we will first accumulate it based on each and every day. So we will sum up all the values for each and every day, and let me understand how the generation and consumption of this particular I would say maybe a small grid or a micro grid, okay, and we want to understand what is the pattern of the energy produced by the solar power plant and how the consumption is. So here in this particular graph, you can see there is a red one, which is the energy which is being produced by the solar power plant, and you have the blue one, which is the consumption by the load 1 and load 2, and the inverter also converts a small part of energy, and it is taking as an AC load to some equipment. We don't know that. And what we also understand from this particular plot is there is a gap between generation and consumption. Sometimes the generation is higher than the consumption. Sometimes the consumption is lower than the generation. So there is a possibility of both things. And then by design, this is also having a battery, and the battery also is getting charged whenever the consumption is less. The battery is also getting charged. So if we recap all the things, it has a rooftop solar, and the solar unit is connected to a energy storage, which is a battery-based energy storage, and there are two loads connected directly to this particular solar power plant, and there is an inverter which converts whenever there is an AC load, which is a very small part in this particular data set. So this is the whole data set what we are having. And for the book, the story goes the owner of this particular building wants to understand whether the next day he will get a power cut or not, okay, based on whatever historical data he has. So there are many methods which can be deployed. In this, the author have tried to do a conventional way of predicting it as a classification problem. So what he also did, along with this particular data, he collected from the register of the employees. He also understood whether there was a power cut because of a shortage of energy in the battery bank, okay, or the energy storage. And that is there in a logbook. And from that, he had also collected or for each day whether there was an outage or not. When it is an outage, then it is 1, and when there is no outage, he has marked it as 0. So that column is also available. So the author tries to predict using random forest methodology how the outcome, that is whether the energy is sufficient for that day's consumption or not, based on previous days how much was generated and how much is stored inside the battery, and how much was the load on that particular power plant. So with that indicator, he wants to predict tomorrow whether the remaining power in the battery will be sufficient for the plant to cater the load of that particular building. So that is what he wants to predict it. So there are other ways of doing it. I mentioned one of the way is using a forecasting model. So with the whatever variation we have, we can also forecast what will be the energy demand for tomorrow. We will see in brief how this forecasting works using Power BI, and we will also discuss about how this can be used. Okay, and we can also do this in both ways. One is, I think, very widely used is the REMAX model. So auto-recursive moving average model. And there is one more called REMAX model, which also takes into account some regressive component along with the time series seasonal variation and the trend variation. And there is one more model called the vector auto-recursive that is also being widely used in the community in these kind of Now, let me understand how the author have done in this particular thing based on whatever the code he has shared. So just digging deep into it, you can see like the battery power is getting charged after 6 o'clock. That means when the sun rises, the irradiation increases and the solar power plant starts charging the battery. Okay, and similarly, we can also see the voltage is varying. That means when the consumption is happening, the voltage is reduced in the battery, and when the consumption is, I would say, not at a particular level, and the generation is also there, then the battery voltage is high. So we know like this is how the battery behaves or how the power plant behaves. Okay, so this is just a validation of it. What we did is we segmented for one day and we understood how this particular data is. Just to follow the framework, the cross-industry standard process for data mining. We want to understand what is the business problem and what is the data, okay, data understanding, and after that we want to enter into the pre-processing of the data and then create the model. Now entering into the pre-processing, now we have this as a time series data. So time series data, you cannot digest the data straight away into your model, okay? Especially when things are changing like this. Just see here. So if it is changing like this, all these things, this cannot be directly put into the model because the model has to understand how the variation is. So for that, there are different ways of.
Sir, I think there is some noise in the background. Can you please check?
Now Google. Now is it okay?
Okay, sir. It's fine. Okay.
So, any questions? Maybe it's someone have unmuted or they were trying to ask some question. If there is some question, kindly ask. Is there any question? Okay, sorry, Mr. Aman. I will ask my kids to be quiet, but very difficult, you know that. But, okay, let's see if we are okay. There is now yeah, we were talking about I think data processing, right? So let's process the data. So we have these data, and this data have to be now aggregated. Okay, so for aggregation, we used some methods of aggregation. One of the things is we want to understand whether the generation of the solar plant is considerable, which is charging the battery. Okay, so for that we have created some threshold. So if it is crossing 5 amps, that means there is good amount of generation from the solar power plant, and the voltage, if it is more than 120, then it is a good irradiance, and there is a generation. Similarly for power, battery current, and battery power. So like that, we created a few feature engineering. And we also found like when this particular peak generation happened. So we identified for that particular day how much hours we had the peak generation, or how much minutes we had the peak generation, and we extracted that particular feature also. So now we have a feature, and that feature is being stored into a data frame called day level. Okay, and we also have one more data frame given by the author, which is the outcome. That means whether there is a failure next day or not. So that is also received from the repository of the author, and we joined that inside the day level data frame. Okay. When we are joining it, what we are doing is we are shifting the data by one row. Why we are doing it is the outcome data, or the power outage, whether it will be there or not, that data will come, say, for each and every date. But what we have to do is we have to shift the data for tomorrow for today's feature. Because what we are trying to do is based on today, how the generation and the consumption and what is the power remaining in the battery, we want to predict whether tomorrow there will be a power shutoff. So because of that, what we are doing is we are shifting it. So this is called lead and lag in time series processing. Okay, that is what we are doing it. So now we have this particular data set called day level. Okay, and what I am doing is, just for simplicity and better understanding, I am exporting this particular data into a CSV file. Okay, so the command for exporting is write.csv, and I have to put the data frame name, and I have to give it a name. Okay, so let's give it a name like level.csv. And I can export this. So once I export it, it will be available in the directory. Okay, so I'm going to the directory, go to the working directory, and I'm seeing whether I have this particular CSV file exported. So this is how from the model you can export the feature, and you can use it for your higher understanding. Okay, so it is there in EFR portable. That is the file. But you can also do this way. Okay, so you can select it, and you can also move it to a different folder. That is also possible. Okay, or you can also see it in like, okay, I want to see this particular folder. Can you open it? Be very hard for me to go into each and every, right? So for that, what I'm going to do is I'm going to use the Power BI dashboard. So Power BI tool for visualizing the data. So I have already imported this particular data, but just for showing you the demo, I'm just closing this and I'm repeating the event. Okay. So Power BI is free tool. Power BI is a free tool. You can download it if you have Office 365. I think majority of us will have Office 365 in our laptops, so you can download it for free. But there are other key features which may not be available in the free version, but it's okay. So now the Power BI is getting started, and I have the data exported from R inside, but it will take some time. Okay. So meanwhile, what we can do is we can go to the R and we can see how the model development we are going to do. So now I have this particular data level of the CSV. Let's open that. Okay, this is my data frame, and in this particular data frame, I have say date, location, okay, the duration between which the current is considerably high, or the minutes, number of minutes the solar power plant current is more than 5 for this particular date, that is 2015 December 2. Okay, similarly, voltage more than 100, power more than 1000. Like that, we have taken that data set, okay, with us. And we also have what is the battery charge, or how much percentage of battery is there first and last. That means at 00 hours of today, what was the percentage of battery which is left for me to consume, and end of the day, how much percentage of battery power or energy I am leaving for the next day to get generated, to get consumed. Sorry, to get consumed. Okay. So this is varying from 3.5 means 35 percentage to 70 percentage, and my initial battery is also changing from 35 percentage to 75 percentage. And I have how much is the energy which is being produced per day, and that the range is between 4 to 14. And load 1, the consumption is between 1.5 to 5.5. Okay. And load 2 is 0.5 to 3.5. That is a huge variation in load. Okay, and this is the inverter energy. That means the AC to DC conversion. And you can see like only few times there are more consumption, and it is between 0 to 10. And we have summed up all the consumptions as total energy consumption, and we also have the weekday with us, just to keep in mind, like whether because of a weekday, whether I will have some problems. And these are the two flags, that is like the outcome, and the outcome means whether next day I had a power cut or not. So for example, say here 2015 12/02, December 2nd of 2015, with all these particular parameters, okay, whether I had a power cut next day, that means a shortage of power in the solar, from the solar power plant next day. That is what I am going to try to predict. So if I see how much I have, you can see that I have more number of zeros and less number of 1. Okay. So it is an unbalanced data. We will also see how this unbalanced data we are dealing with when we are working on the model. So for the model development, I have used this particular random forest. Okay. So first thing what I'm going to do is I am going to split the data into 2, so that I can have only half book given to my model, and the remaining half is there with me. Based on that, I can take some questions and ask my model whether it is able to answer with whatever it is it have learned. Okay. So let me do that. Okay. So now I'm splitting the data into test and train. Okay, so this is all the codes. Just you have this particular code, and you have to just change instead of day level, whatever is the data frame you are creating. So it is majority of the things are being usable. Okay. So and I'm using one of the widely used structure. Okay. So I think random forest is not there in my computer, so I have to install it. Install it. Pages. You can do it like this, or there is an easy way of doing it also. You have to go to packages and click on install. After that also you can install it. It's both ways it is possible to do it. So now my package is installed, and I'm commenting it so that next time when I am doing it, it's not needed. So now random forest is there with me installed already. So I am calling the random forest, and I am writing a formula. The formula is kindly predict my outcome. That means next day whether I will have a power cut or not, based on how much time the generation from the solar power plant is more than some considerable level, and what was my consumption, okay, and what was the energy left in the battery, and what was the energy in the starting of the day was, okay. So with all these things, I am asking it to fit a random forest, okay. So let's ask it to create, okay. I think it's done. Okay. Now I am having a test data with me. That means I haven't given the test data to the model because it will overfit. That means it will try to by heart it. So I am preserving some questions with me, okay, which is not known to the student. That means my model doesn't know this. Okay. So I am asking data to predict that particular value of whatever I have been given to that particular model, and I am asking it to give me what is the performance with the test data. Okay, so if you see the test data, test. So, factor. Okay, so there are 21 days without any power shortage, and there are 10 days with some power shortage. So this is the data we have given to the model to predict it once again. Okay, so let's see how we have done it. Okay, so among among the 31 different data what we have fed, okay, it has predicted the zeros. That means there will not be any power cut next day 18 times perfectly, okay, there is no problem. But some 3 times it has not predicted it well. That means next day actually there was a power cut, but the model have not predicted it. Similarly, there was a power cut, but sorry, there was not a power cut, or the power was not a shortage next day, but the model have predicted there will be a shortage. Okay, so 6 times it has done that, and 4 times it has predicted like yes, there will be a power cut. Okay, so this is how the confusion matrix looks like. That is the performance of my model. So overall, if you can see, and what is I would say like the sensitivity or specificity. Okay, those two things. What is the true positive rate and true negative rate? I'm having like the true positive rate is 0.4. Okay, so which is a little worrying for me, but this can be improved. There are some methods where we can handle unbalanced data, and we can either do an oversampling, okay, or an undersampling for the model to better understand how these things, especially with industrial data, where unbalanced classes are there. Okay, so for creating an unbalanced class, what I did here is, okay, I try to increase the number of ones. Okay, so for example, it was 2110 before. Now I have changed it to 4750. That means I have created some new data so that the data set is balanced. Okay, so with this particular thing, again, I'm going to ask it to predict. Okay, so now it has once again done model fit. Okay, and I want to see how this model have performed. Okay, so now the model have completed its testing, and again let me see whether I'm able to get a good result. Data test outcome. What I'm doing is I'm doubling the number of training, okay, so that my model gets trained well. So it is getting trained well with the new train. Yes, new train, but even after that, I don't know. My performance is not good. It is the same. It is the same. And my true negative rate have also deteriorated. Previously, it was 0.9, if you recall. It was 0.857. Same. There is no difference in the model performance. So probably we have to do a different type of a modeling, but 70% is also a decent accuracy to the industry standard. Okay. So with a 70% accuracy, we are able to predict whether there will be any problem or not. Okay. Now I want to next understand. Okay, tomorrow I will be having a power cut. Okay, so what are the different parameters which is predicting this particular occurrence? Okay, so if you see, this is called like a variable importance plot. Okay, that means what are the variables are creating an impact on the final outcome. Okay, so one of the variable is if there is a variation in my load to energy consumption, there is a variation. So if the variation in load to energy consumption, if I'm able to reduce it, I'll be able to have without any power cut as per this particular model. And the how much energy was left in the battery, obviously this also is very important, and the total consumed energy. But if you see, there is a covariance, so both of things will have the same variability. So according to me, either one have to be used. Okay? And maximum solar voltage and mean solar voltage, maximum solar current. So these are all the other things, but we have to see whether there are some covariance with this particular data. Okay? So this is the variable importance plot. Okay, so it is called the variable importance plot. This is just to give you an idea of how this particular machine learning techniques can be used for even a classical engineering problem. Okay, this will give, I would say, like when you are digesting large amount of data and you want to understand the variation in the particular data and how the variation is impacting the outcome. Okay, so if you want to see that, you can use this. So now let's go back to our Power BI. Okay, so as you told, so the Power BI is a business intelligence tool. Okay, so that means you can create beautiful visualizations using Power BI. Okay, so now it has opened, and this is how the normal screen will look like. Okay, so there is something called get data here. Okay, you can click on this, or you close this and you go here into the home menu. Just below that, you will have something like get data. You click on this, and then you have to browse to the type of data. Here we have given the data or exported the data as CSV file. So I'm selecting at its CSV file, and I'm asking it to connect. You have a lot of options, so you can be used at the same time. Taking it here. Okay. Let's open it. Once the connection got established, then it is very easy for us. Okay, it will say like, okay, this is how the data is looking like. Okay, the first 200 rows. Are you okay? Do you want all this particular data to be loaded? According to me, it seems okay. So I'm saying like, okay, load please. Now it's loaded. Okay, so now the data got loaded. So now let's imagine I have one of the, there are a lot of visualizations. Let me introduce you. So this classical bar chart. Okay, so let's see, like I want my F bat, how much was my battery percentage. Okay, so I have to just type what is the column name I need, drag and drop into the value column, and I want my date also. Okay, so you have your date, and drag and drop the date here. Okay, so then it will look like something like this. Okay. So maybe for you it may look odd. It's because like it will do automatic summation. Okay, so what you have to say is, you don't do a summation, you do an average. So you can see like if there are some, for example, let me take this one. Okay. So let me drill down. Say, for example, I want to see in 2016 how the performance was. Okay, so I have to ask it like I'm going to do a drill down. Then you double click it. Then it will open for each and every day how it is. On January, how it is, on February, how it is. And you can also I don't want to see based on every day. I want to see for every month how it is at an average. So at an average in January, okay, obviously we know it is not a sunny month. Okay, during that time the percentage of battery which was left for the next day consumption at an average it is 56%, and on February it is 56.06, and in March it is 60.17. Okay, and we all know this will be something like this because March we have the summer, right? Now I can also compare, say if this is my day beginning, the battery percentage. Now I want to see how my last one is. Okay. Similarly, I have to convert that into average. So I can have something like this, okay, or I can ask it to plot something like this, next to next. Okay, so there is no much difference. Okay, so it is almost hanging less than 60%, less than 60%. So can someone give a pointer here? Okay, for this particular problem, what is the solution engineering way we can do? Can someone give a suggestion? That means the battery is not getting charged to not more than 60%. So what is that we have to do? That means we have a capacity to charge, okay, but what is the problem what we are having? So how I can improve the amount of energy inside the battery to be okay. Obviously I cannot ask my consumption to get reduced. That is the value add and consumption that we are should maintain. So what is that I have to do? I hope all of you are following. Can I have some response, please? Yes, Mr. Anand.
It may require maintenance. Is not.
Yeah. Wonderful. Wonderful. That is that can be a very important thing, which is I would say there is no cost for it. Okay, we can have a maintenance. That means we can clean the say the solar panel so that we can capture the maximum irradiance. Is one. And I think there is one more indicator from here, your storage capacity is more than the generation capacity. So it is like a 60% only you're using the storage capacity. And that means just imagine you are getting rain, but your dam capacity is not or I would say the other way, you are getting a rain which is less, but your dam capacity is very big. Okay, only 60% your dam is getting filled. So what is that we have to do? Either we pray to God we should get more rain, or we can also see okay, can we borrow some rain from outside? Okay, or that means water from some other states. Okay, similarly here in this case, what we can think of is my battery capacity is good, my energy storage capacity is good, probably I should add a few more panels. Okay, so the very important aspect is the energy storage device have to be almost operate between I would say it should get charged fully. Otherwise what will happen is there is something called a memory problem in a battery type of energy storage. Then it will say okay, boss, I am used to this kind of charging only so I cannot charge more, I cannot retain more energy. So probably here in this particular thing, if professionally, if we have to give them some suggestion, is like you have more battery capacity. That means a bigger dam, but the amount of water which is coming inside the catchment area is very less. Probably you have to increase the number of panels. Okay. Otherwise, whatever investments you have done for this particular battery storage or for that particular dam is of no use. Okay. So that is the pointer what we can give to our clients. Okay. I hope you all agree, or you have some different thought. Mr. Anand, I see you are raising your hand. Is it like you have one more something else to ask? Okay, that may be by mistake. Okay. So now there is one more beautiful function which I would like, I would say like I like it more. Okay, so this is called the key influencer. So what this particular Power BI gives is it also gives us some interpretable things. Okay, so one of the interpretable things is this. Okay, say I have my outcome. Okay, which is what I want to analyze. Okay, I want to see whether tomorrow I'm not going to get power cut. Okay, so that's the thing. Okay, so now if I put outcome, putting it. So I have to change this. So what has happened is it is taking the ones and zeros as a numerical value. So I have to ask the ask Power BI not to do that. Okay. So what I have to do is I have to just click on this, like in our Excel, how we do the same way. So I have to change this particular type. Okay. Say I will change this as true or false. Okay. That means whether there was an outage or not. So 1 as true, 0 as false. So I think now it will get changed. Okay. So if you see, yeah, now you see what influences to be false. Okay, that means outcome to be false. Now I will add here, say my battery things. Okay, so I will say like, okay, use this particular battery thing. Okay, and then use my another battery, expand your analysis and give me some, and let's see, like I want to see the solar energy, something is that maximum solar power. Let's add this. Okay, maximum solar power and mean solar power, because it is not picking it. That means it is not a very good variable, okay, for it to predict. Okay, so you can see here these things are not becoming a very good way. So what we will do is we will select all the things which was shown by this variable plot. Okay, say load to energy, right? Load to energy. Let's put it the order what it has. On second is AF pack. Third is total energy consumed. Okay, and then is max solar voltage, mean solar voltage. Max solar voltage. Colleagues or friends, what I want to tell is it's very easy for you. It's very easy for you to use this. So, I think this one. So if you use Tableau or Power BI kind of tool, it becomes very easy for you. Okay, so now what it has done is it has done a prediction. So the prediction says like the outcome, that is let me change this particular outcome as outage. Change it as power outage. False, yeah. What influences power outage to be false? Okay, so I don't want false actually. I want true. Okay, yeah. what influences my power outage for the next day to be true? Okay. First thing is if your F-bat, that is the amount of energy which is left inside the battery, is 62% or less. Okay, the power outage is becoming true. Yeah, very good. So there is no remaining power in your battery, and because of that, you are having that problem. Yeah, we know that. Next is mean solar voltage. If the mean solar voltage is more than 73 volt, okay, then you are getting more than 73 volt, then you are getting the power outage to be true. Okay, this is something we have to investigate. Probably the domain expert will not agree to this, or we have to remove this. Okay. Third is it is saying like the total energy consumed. If it is more, obviously I'm going to get a power outage. Obviously, when you consume more energy, your battery will get drained. That means from your dam you are consuming more water. Then next month you will have shortage of water. Third is if the solar voltage, maximum solar voltage, is between 192 to 192.5 to 192.6, you are getting the solar more outage. This is also something strange. Okay, so this is something like a statistical way of dealing with whatever data we are having. So what this functionality helps you is it will help you to understand how your decision that model is taking. Okay, and here they are using many models, and it is also like a collaborative AI. So you can say like I don't like this particular model. Okay, so I will say like it is very hard to understand. You say like that, then what will happen is this will also learn and it will say like, okay, this type of prediction is not working for this particular person. So next time it will change its way of interpreting. Okay, so that way it is a good feature which is there in Power BI. Very easily you can use it. So now next feature what I want to introduce is this decomposition tree. Let's do the same. Okay, I will feed this outage. Okay, analyze the outage and use the F-bat. Okay, same. Okay, whatever we are having. Okay, so we have to just. Okay, you can see it will give you a visual of the power voltage, which is like whether it is true or thing. Okay. Okay, so this is one way of seeing, which is called a decomposition tree. The same like the earlier one. You can also add many variables to it, so it will become very nice as a tree. You will be able to see it. So that is one another visual which will be helping you. And there are other visuals I also introduce you. You can also get more visuals from the internet. Okay, you have to sign in. Okay. I think it will take some more time, but let's try if it happens. I think it will take time. So let's leave it. So now let's go back. Okay, let's see what's fast. I will show you. You can also download more visuals, and there are very good visuals. And you can also have your R and Python integrated, and that is another thing. What you can do. I think it will take some time. Let's go back to R and come back if time permits. We will also see this. Okay. Now there is another thing called line package. So I'm just installing the line package. We have discussed about how the Power BI is helping us to interpret. Install packages line. Let me see whether first I have the line. have to install it. Okay, after installing, I'll be able to use this particular line package. Start. So let's call this particular path. Let's come here. Now let's go to help. Line. And you have this. So first thing is what is the full form of line? Okay, so this is something which we have to understand. So line is I would say a linear way of decomposing the things and understanding what it is. Okay, so it follows some steps. First step is for each prediction. Okay, it will use an explanation function like how we have seen in the Power BI. Same way, it will ask for with which data you want my decisions to be explained. So it will ask for each prediction which data I have to use for explain. Then it will create a permutation with the number of n is a variable which we have to feed. This can be customized, but again, the default value also will work. So it will take some few samples, and with this particular sample, it will see what the model is predicting, and for each of that particular sample also, it will apply the same model, and it will try to understand how the model is taking the decision. And based on that, it will say like this model has taken a decision with this particular data set, and what I have done is a similar data, which is having a similarity to the data set what you have fed. I have searched with my dictionary or with the historical data which is left with me, and with that, it is if I explain it, this is how it looks like. Okay, that is how it will do the explanation. And what is the other advantage what we have is you don't have to or it is not like it gives an explanation based on the variables it has in its mind. You can ask like if I use this particular variable, what is going to happen? Can you explain? Like that, you can also certain variables and ask whether this variable is creating a problem or this variable is creating a problem. So in that way, it is a I would say a decently performing explainable AI as of now. And there are a few packages which are being researched, and it is going to come very future in future. Okay, so this is the general structure of how this particular line works. Okay, till here it is a linear discriminant model, which like in a medical data they have created it. In our case, it is not a medical data; it is a power data. Okay, and the same the prediction and other things what we have seen in our case same. Next to that, after the model, what we have to do is we have created two variables, which is the explainer, explanation, and we have to ask it to explain. Okay? So these are the things. So what I'm going to do is I'm just copying this particular piece of code, and taking it to our and you also have one more beautiful Keras-based example in the help also. Okay, this also you can use it, but I'm not using it. I'm going by this particular website. Okay, so let's see what all the things I have to customize. Okay, so let's eventually something like this. Okay, so what I have to do is instead of biopsy, I have to put our data set name. It's day level, right? And I think I have used instead of minus test set, I think I have used only test. Let's once check it. I think I used test. So this is minus 20. Okay, something like this. I hope it. So minus 20 samples. So minus. So that is means I am giving it a test sample. So or my train samples, because minus of test is my train. Then I have to pass in the model. Okay, in our case the model name is let's see what is the model name. It's fit or new fit. Let's pass on new fit. This is a model name, right? Let me pass this name, and I can ask it to explain. So now you can see here it has created one set of that means based on the data and based on the model, it tried to learn how the model is working, and it has created certain data sets with it, like a density, the feature type, and other things, the frequency distribution. So now it knows like what are all the things which I have to use for explaining something what the user is asking. Okay, so it is saving the explainers. Now I have to ask it the explanation. You give me an explanation, please. Okay, so here what I will do instead of this, I will ask it to explain my test data. So here the minus one. So I have the explainer already. So I have asked it to explain it. So what it has done is it has created the explanation, okay, for me. So, okay, some error. The model of supported output. Now it has created an explainer, and with this particular explainer it will be able to give me an explanation of whatever new data I'm going to feed it inside. Let's have a close look of how it is working with the example, and then we can compare. Okay, so you can see here, so when it is giving an explanation, it is saying like there is a probability of this particular data set to be I think this is Benin, this biopsy data which is coming outside, and it is detecting whether it is a cancer or a non-cancer tissue. Okay, and it is saying like it is a Benin, okay, because the bar nuclei is less than or equal to 3.25. Clump thickness is less than or equal to 3.25 or something like that. It is making it. Okay. So I understand what my error I'm getting it. So let me so it is not working for this particular model. Probably there is some version problems. No problem. Let's see what this LDA and what is the syntax so that we can customize it. It is part of the part of the mass library. Yes, it's mass library. I think I have this library. Mass. I have a library now. Done. Now, what all the things I have to do here is I have to feed some hyperparameters to it. Okay, so So I have to give what is my data, what I'm going to use, and what is the prediction, what I'm going to make. These two things I have to give it to you. Let's give this. Let's copy this and use it in my. Okay. So waiting, and after that they are getting something like this. Okay, so this is the outcome result, okay, which is my outcome. I have to put it like outcome, and I have the features to be in the first step, and I have to put the outcome in the last step. Okay. Let's see. So these are all my predictors. This is my prediction. Then I have to give it like data. Good data. Okay. What is the data set I'm going to use here? So what is the data set? It is train. Let's check it. So it has done a model prediction now with the LDA pack. Okay. Now I think line is already there with this. And we'll change here this model. That is the name what I have given, and I will say like, okay, this is what you have to do. I think change is required. Now let's create a that now. Okay, now it is asking. I'm asking it to give the explanation. Yes, now it's okay. So I can have the explanation before it finishes its work. Let's see how to plot it. I have to use this particular command, plot. Yes, so let's come back. Let's ask it to plot it. Yes, it's too crowded. So the number of samples. Okay, sample. How many things it has? It has more variables. That is the result. Let's see the dimension of it. Dimension. It is 31, right? So make it like I'll feed only the first one. Not yet. Okay. Some warning. Let's ignore that. That's important because when you feed more, then it will be a problem. So let's spend some time in this particular explanation. So now this is case number 6, okay, and the model have predicted it like tomorrow you will not get an outage, okay, and the probability statistically 70% it is I would say is the probability at which it is making that particular decision. Now there are two things, one in blue, another in red, what you have to see. Okay, so one in blue is something which is supporting this decision. That means the model is making the decision, and what is the variable which is supporting that particular decision. The decision here is it is detecting like tomorrow you will not get a power outage. Okay, the support what it gets is because the solar power generation is more, so because of that you will not get a power cut, no problem. Second is the current is also good, okay, that is the second one. And there are some contradicting figures also, which is also the thing. That means the remaining 30%, why you will get a power cut, maybe the 30% chance is there because the duration, the battery current was more than a specified limit. That means more discharge has happened is 379 minutes in the last day, and the max current, okay, max solar current is between 10.3 to 13.0. So these are the two things which contradicts the decision of the model, and this in blue supports the model in making the decision, and it will rank it based on its importance. Okay, so this is the thing what you can understand after it is predicting. See, now what happens is when you are having something like a black box model, my random forest is saying like it will be 0. Okay, then for your any customer, as well as if you make something wrong in your model also, that will get visible when you are explaining it. Okay, but we don't want to do something wrong, right? So by the normal way, we want to do a very good job, and we also want to understand how the model is working. Only then we will be able to fine tune it. When you explain the model with this kind of chart, what will happen along with the domain expert, you can also validate. It is making the prediction like this. Do you think this is right or wrong? Okay, so then the customer also, or the subject matter expert also will be information. So that is the important aspect in line. So now we have seen this for the one of the data. Okay, let's see for the other type of data. That means, let's see, I have a power outage data also. Yes. Is that. So it is 1, 2, 3, 4, fourth one, right? So I have to feed the fourth one, then I will be able to get something for bad. So I'm just copying this particular for creating new one, and instead of 1, 3, I have to give it 1, 2, 3, 4. 4. Okay, so rest of the things I don't have to disturb. So this I can. Now another new day, another new data, you are feeding it inside, and you want to understand how it is. Okay? And you can also increase or decrease the number of features. You can also add it like 5. So now I am asking it to do the prediction. So now you can see like it is detecting. It is detecting like tomorrow surely you will get a power outage. That means label 1. That means you will get an outage, and the confidence is 90%. 90% it is confident you will get a power outage. And what is contradicting is the solar current is more. That means there is good generation. Okay, but the current is high, but I don't know why the maximum solar power is in a lower band. Okay, this is also contradicting. The subject matter expert have to deeply look into it. Why this is happening? Okay, why this is happening? And the current more than some limit, threshold limit. That means the battery charging current was less than 379 for was less than a threshold for 379 minutes. Okay, so that is the reason you will get a power cut tomorrow, and the duration is also less. That means you getting a very less number of hours where you got the generation. So it is only 470 minutes you got the time for the solar panel to generate. Okay, and similarly, the power duration is also between this particular level to this particular level. So these are all the reasons why I am predicting like tomorrow surely you will get a power outage, and the probability of success is 0.9. Okay, so these are all the things where we have to really investigate whether the model is working or not. Okay, otherwise sometimes it will be like a bad model, but based on that people will make a decision. Say like your train, the probability of getting a confirmation. Okay, it is showing 0.7, but you cancel the ticket, but you can see like someone who have booked the ticket after you got the ticket. Okay, and you both are there in the railway station and you're waiting for the next train to catch. Okay, so that is the thing what will happen. Okay, so when we are discussing with the customers, we normally use these kind of line package so that we explain our decision, how my model is performing. Okay, so any questions so far till this? So actually I have prepared this particular example in the cloud platform, but somehow I don't know what happened. The cloud returned an error and suddenly it got terminated. Okay, so because of that I have to redo everything before you. Probably we have wasted some 10-15 minutes because of that, but again it's a good learning for any questions or any questions you want to ask me, some queries. Yes, please unmute yourself and ask. Okay, so Gokul, can you confirm whether you have sent that code to the participants?
Yes, sir. The date itself I sent.
Yeah.
Actually, I have one doubt.
Yes, Gokul, please.
In the R itself, we have visualization, right?
Yes. Yes, we have visualization. Yes. Gokul, please go ahead. I'm not able to hear your second. Yes, R is also having visualization. Yes. Yeah, maybe what I understand, maybe your question is like if R is also having visualization, why we are going to Power BI? Maybe that is your question. So if that is your question, let me explain to you. Like you see, we have to create a lot of codes in R, right? So it becomes very time consuming when we have to quickly digest the data. Okay, but here it becomes very easy for us to do the plotting. Okay, so just I have to drag and drop the visuals. Okay, say like I drag this and put it here, and I drag this particular data, put it here. That's all. My graph is done. So in that way, my Power BI is much faster when I am doing the exploration of the data. That is the reason we use Power BI. Again, it is not a cost to the company, right? So you have this fee. This also has a advantage, like you can publish this in Azure platform. So you can have a mobile dashboard. Obviously, R is also that having that functionalities, but again, it is some companies will not prefer it, so they will go with these kind of commercial tools. Tableau, Power BI, ClickView, those kind of Power BI. This is any other questions? Yeah, Google. Any other question? Sorry, your voice was cracky. Probably you can also type in your questions in the chat window. Please, everyone, if you have some difficulty, you can also type. Thank you. Thank you. Any other questions? Mr. N. Anand, you have raised your hands. So is it by mistake or you want to ask some question? Okay, friends, thanks for joining. Again, as always, I'm a little unhappy. We are not having conversation. Okay, unless otherwise the sessions you are asking some questions, it will not look nice. So kindly, in next sessions, kindly prepare some questions. And I think all of you have received the. Can you all confirm whether you have received the code in the chat window, please? Students, at least please confirm whether you have received the email or not. Probably you can also put again, it is Microsoft Teams offline also. You can put your chat comment or reply to the organizer, and if there is some help you want, like the course not reach you, you can also get in contact. Thank you all for joining. Wish you all the best. Okay, see you all in the next section. Thank you.